What is the strangest thing humans have found on the moon? It is not a secret base, but something that should not exist at all, a thing that should never have been there. With the upcoming debut of our crewed lunar landers, this discovery has become extremely important. More than 50 years ago, when Apollo astronauts last walked on the moon, over half a century has passed. No human footprints have touched that ground again. But we have thrown dozens of probes at it since then. Some landed successfully, some flew by, and some were deliberately smashed into it, just to see what kind of splash they could make. Overall, the moon is the celestial body humans have played with and studied the most. But even after decades of research, the moon is still full of mysteries. Whether it is the way it stores heat, how it conducts electricity, or even the properties of its soil, we still know far too little. The universe seems to work this way. The more you study it, the more questions you get. We were full of excitement before sampling the soil. But after bringing the samples back, we discovered one after another chemical traces that should not exist, leaving scientists scratching their heads for decades. You might think scientific discoveries immediately change everything. But real scientific progress is very slow. Sometimes everyone notices it, yet no one believes it. This story starts in 1976, when the Soviet Union launched an unmanned probe called Luna 24 to the moon. It was their last trip to dig soil on the moon. At the time, nobody cared much about this mission. It was not the first, and the scale was not big, but it quietly did something big. It drilled about 2 meters under the lunar surface, extracted a small core sample, and sent it back to Earth. The whole sample was only 170 grams, about the same as a baseball. Not much, but inside that narrow tube of dust, something strange appeared. Traces of water. About 0.1% of the sample contained water. And the deeper you studied the sample, the more water you found. This should have been a big deal. But instead, scientists thought the water came from Earth, that the sample was contaminated, perhaps from the lander, or from equipment on Earth. Because the textbooks clearly said, the moon is dry. It cannot have water. And this was not the first time. Earlier, Apollo astronauts had also found similar hydrogen signals in their soil. But those were also dismissed as contamination. So, these clues that should have caused a sensation collected dust in the corners of lab reports. For decades, no one mentioned them again, until the turn of the century, when people finally realized we might have missed something important. But by the time we were ready to go back and check, the moon had prepared even more puzzles for us. If you were dropped near the edge of some craters at the lunar poles, you would see an almost unnatural scene. Not because something is there, but because there is nothing. Not even light. Only permanent shadows that have never moved for billions of years. These areas are called permanently shadowed regions. Why is that? Because the moon stands unusually straight, with an axial tilt of only about 1.5 degrees. This means, when sunlight hits the poles, it barely grazes across the surface. The craters are large and deep, so sunlight cannot reach inside. These places have almost never seen a single ray of sunlight throughout the entire history of the solar system. Not only extremely cold with no thermal cycling, the coldest spots can reach below -240 degrees Celsius. Colder than distant Pluto. arguably the coldest places in the entire solar system, scientists started wondering in the 1990s if comets or asteroids had ever hit the moon, bringing water with them. Could some water vapor have drifted into these craters and remained frozen there forever? This idea quickly became popular because it meant the moon might not be just a dry rock. It could be a resource warehouse, a future gas station in space. From then on, all eyes focused on the moon's poles. Watching from Earth was no longer enough. We had to get closer and see for ourselves. But the problem is, these most promising places are also the hardest to reach. Complex terrain and no sunlight. Solar panels there would be completely useless. Yet the temptation was too strong. What if there really is ice? So wave after wave of exploration missions were sent, with only one goal: find solid proof. And right at that moment, things started getting strange again. Scientists suspected there was ice. So what next? Send a scout to check. But landing directly was too risky. So the first few missions just orbited and observed. The first one was NASA's Clementine probe, launched in 1994. It was not looking for water. It mainly mapped most of the moon's surface and confirmed that the South Pole indeed had large permanently shadowed craters. But it did not carry the right instruments, so it could not confirm if there was ice inside the shadows. Then in 1998, NASA launched the Lunar Prospector. This time it was specifically hunting for water. It scanned the moon with special instruments. And in both poles, especially in the shadowed areas, it detected large amounts of hydrogen signals. This made scientists extremely excited. Theoretical estimates suggested there could be tens of millions, or even hundreds of millions of tons of ice. This was not just a puddle of water. It was a discovery that could change the entire future of space exploration. But the problem came back. Detecting hydrogen is not the same as finding water. It could be part of solar wind, or locked inside minerals. The instruments could not tell the difference. They could only tell us there was hydrogen-rich material, but not whether that hydrogen was part of water ice. So what was it really? In fact, even orbiting spacecraft could not see it clearly. So it was not solid evidence yet. This made the scientific community scratch their heads again. We had data and clues, but no final confirmation. It was as if the moon was telling us it had a treasure, but would not let us open the box. So scientists thought, since we cannot see clearly from orbit, then let's be straightforward. Just smash into it. You heard correctly. We are going to crash into the moon. The logic was simple. If the ice is hidden at the bottom of the crater, and we cannot see it from above, then we smash something hard into it. Blow the material out into the sunlight, so we can finally see it clearly. This method is simple and brutal, but it works. The first attempt came from Lunar Prospector. After completing its mapping mission in 1999, it was crashed into a crater near the South Pole. Unfortunately, this attempt failed. No water was detected. The results were inconclusive. Some said the impact angle was wrong. Others said it missed the ice. 10 years after that failed impact attempt, in 2009, NASA's Lacrosse mission brought a turning point. This time they did something spectacular. They brought a Pathfinder, the spent rocket upper stage that carried it. They first slammed this big chunk of metal, like a cannonball, into a crater near the South Pole called Cabeus. A few minutes later, The Lacrosse spacecraft itself flew through the debris plume and analyzed it on the spot. This time it succeeded. Instruments detected water vapor in the plume. This was not a hint, but measurable real water. Not only water, but also methane, ammonia and other substances. This was the first time humans had truly touched water on the moon. Headlines around the world reported it. Scientists celebrated with champagne, feeling the decades-long mystery was finally solved. But new questions soon appeared. We made the impact. But how much water is there exactly? Is it solid blocks of ice? Or ice mixed with soil like permafrost? Most importantly, is it easy to mine? Lacrosse gave us the answer. But it destroyed itself in the crash and could not provide more information. We only know there is water at that spot. But the full picture of the moon is still a mystery. For a long time, everyone's thinking was straightforward. If the moon has water, it must be hidden in the coldest, darkest permanently shadowed regions, places where sunlight never reaches, like giant natural freezers, where ice could stay for billions of years. The logic seemed perfect. But the moon always has new tricks. Orbiting probes, such as NASA's Lunar Reconnaissance Orbiter, which has been circling the moon since 2009, and India's Chandrayaan-1, began detecting faint water molecule signals, even outside those icebox craters on the sunlit lunar surface. This completely confused everyone. Looking for water in places exposed to sunlight, where daytime temperatures can exceed 100 degrees Celsius, should not the water have evaporated completely? Even more baffling things followed. Scientists discovered these water signals are not constant. They actually follow a schedule. At noon, when the sun is strongest and the surface is hottest, the water signals become weaker, or even disappear completely. But in the evening, when the ground cools down, the signals return. What is this? Is the moon sweating? Sweating during the hot day, and pulling it back at night? This phenomenon completely defies our understanding. The moon is in a vacuum environment, with no atmosphere. Keep in mind, the moon is a vacuum environment, with no atmosphere, no air pressure, and certainly no wind, rain, or thunder. On Earth, water evaporates, condenses, and forms clouds and rain. That is called the water cycle. But the moon is completely naked. So where does its water cycle come from? This is absolutely one of the moon's top-level mysteries. So where exactly does this water come from? Scientists scratched their heads and came up with several possibilities. One theory is it was delivered by visitors from space. Every day countless tiny micrometeorites, like dust, smash into the moon. Some of them may carry a little water themselves, or they slam into lunar minerals, knocking the trapped water loose. Another theory is even more interesting. It says the water comes from the sun. The sun is constantly blowing outward a stream of charged hydrogen ions, what we commonly call solar wind. When this wind hits the moon, the hydrogen ions collide with oxygen in the lunar soil, and right on the spot they synthesize water molecules for you. Regardless of the source, this discovery completely changed the game. It means we may not have to go to those extremely dark and cold, extremely difficult to develop polar craters anymore. Perhaps the entire lunar surface is covered with a thin layer of water. Now it just depends on whether we are clever enough to collect it. This instantly expanded the possible locations for future lunar bases by countless times. This highly tempting possibility directly gave birth to the next generation of exploration missions. Then in 2023, Indian scientists also took on this ultimate mystery with the Chandrayaan-3 landing probe. And its target was the South Pole. This is also the region scientists believe has the highest concentration of frozen water on the Moon. This was the first time humans successfully landed a probe at the South Pole. Everyone watched with wide eyes, waiting for the Pragyan rover to send back news that it had found ice. The rover started moving, using lasers and X-rays, analyzing the soil thoroughly. The result: iron, calcium, titanium, everything was there except hydrogen. No hydrogen meant no water. Everyone was stunned. Where was the promised water? It was clearly marked on the maps. Had we been wrong all along? Or was the water buried too deep, beyond the reach of the rover's small shovel? Before anyone could figure it out, the 14-day lunar night arrived. Temperatures plunged below -100 degrees. Chandrayaan-3 could not survive it, and fell into eternal sleep. What it left us is an even bigger mystery than before. However, Chandrayaan-3 did not go in vain. Before it died, it accidentally used a temperature probe and discovered a key clue. It measured the temperature of the lunar soil. The surface heated by the sun reached over 60 degrees. But just 8 centimeters deeper, the temperature dropped sharply to -10 degrees. The temperature difference is huge. What does this tell us? It tells us that the topmost layer of lunar soil acts like a thick insulating blanket, preventing external heat from penetrating inside. This perfectly explains why the rover found nothing on the surface, because the water ice is most likely hiding just a few centimeters beneath this down jacket layer, safe and undisturbed. So it is probably not that there is no water, but that our previous shovels were simply too short. So the question is no longer whether the Moon is dry, but whether our tools are sharp enough to perform proper excavation. If this is true, then the next lander will not need to fly farther or see more clearly. It will simply need a much stronger drill. For decades, the search for lunar water was viewed as pure scientific curiosity, a better way to understand the Moon's history, its geology, and how water moves through the solar system. But that is no longer the main reason people are interested. Today, lunar water means something much more direct. A launching pad for humanity to go deeper into space, and the cornerstone of future space bases. Because if we can find usable water on the Moon, enough to extract, purify and store, it will unlock everything else. First, it makes long-term lunar missions possible. Water is heavy. Launching it from Earth is very expensive. Water delivered there is worth its weight in gold. But if astronauts can obtain water locally, they can greatly reduce the supplies they need to carry. This water can be used for drinking, cooking, cleaning, or cooling equipment, without relying on constant resupply from Earth. Second, water can be split into hydrogen and oxygen, the same fuel combination used by many modern rockets. If we can build a system to extract lunar water and convert it into propellant, then the Moon will no longer be just a destination. It will become a gas station, a place where spacecraft can refuel. before heading to deeper space. Mars asteroids or even farther destinations. This completely changes the entire calculation. Currently, every mission must carry all its fuel from the very beginning. But establishing a resource supply base on the Moon can greatly reduce the load. Launching from the Moon is also much easier. Its gravity is only 1/6 of Earth's. This means less energy, lower costs, and greater flexibility. Spacecraft launched from the Moon do not need giant rockets. They only need a modest thrust. Third, local water changes the way we build. It can support closed-loop life support systems, recycling waste into usable resources. It can even help grow food. Some plants can grow in lunar soil under controlled conditions, but they still need water. If we find enough water, future habitats may no longer need to rely entirely on supplies airdropped or delivered from Earth. It can be said that this will play a pivotal role in the future of human space exploration, although we are still uncertain exactly how much water is available or how easy it is to extract. Because all of this, fuel bases and missions beyond the Moon, can only be realized if we can first successfully extract that water. This brings us to the final question. Despite so many missions, so much data and optimism, the truth is, we still do not have a clear path. Every time we feel like we have finally figured out the Moon, it brings us something new. A contradiction, a missing signal, an unexpected result. And this pattern keeps repeating. We see strong hydrogen signals from orbit, but none in the soil when we land. We found traces of water in the impact plumes, but no frost, no ice sheets, no visible accumulations, even in craters that have never seen sunlight. Places cold enough to preserve ice for billions of years. High-resolution cameras still have not captured any clear ice that actually looks like ice. Instead, what we get is ambiguity. Shallow probes found nothing. The water detected by instruments seems to disappear during the day. Rovers have crossed craters that should be full of frozen material, yet only found more dust. Even new technologies like shadow cameras, although capable of imaging the darkest places on the Moon, have not yet revealed the kind of clear, reflective ice blocks that scientists hope to see. This raises an unsettling question. What if we have been wrong all along about how the Moon stores water? What if our models need correction? Or even worse, what if the water does exist, but it is distributed so thinly, buried so deep, or bound so tightly to the soil chemically, that we are not yet ready to extract it? Of course, looking at it optimistically, perhaps our tools, although precise, are still not good enough. Our orbiters are like eyes suspended in the sky, seeing widely but unable to touch. Landers and rovers are like outstretched fingertips, able to touch but unable to dig deep. All our explorations feel like scratching an itch through our boots, always feeling just a little short. The spectral data sent back is also full of riddles. It tells us there is hydrogen here, but does not say whether it is hydrogen from water or hydrogen trapped in rocks. It tells us this area is bright, but does not say whether the brightness comes from frost or from some special mineral. But the word "give up" does not seem to exist in the human dictionary. On the contrary, the more mysterious and foggy it becomes, the more our curiosity is ignited. New missions are lining up, stronger landers are being built. All eyes remain fixed on that place where we firmly believe the treasure is hidden. The next mission may bring more advanced drills. It will carry deeper drills and smarter extraction systems. No longer just probing, but finally breaking through that last layer of window paper once and for all. From beneath that insulating lunar soil, to scoop up a handful of cold and solid future, of course. The moon may play another joke on us, letting us discover even more unsolved mysteries. But when our drill finally pulls up that cold and solid future, a new era far greater than the moon landing itself will officially begin. By then the blue planet beneath our feet will no longer be just a famous cradle, but the harbor from which we sail toward the sea of stars.